What specific problem does WEBDREAMER aim to solve within the context of applying planning algorithms to online web environments?
WEBDREAMER aims to address the significant safety risks and challenges associated with applying planning algorithms to online web environments, particularly the dangers of irreversible actions and hidden vulnerabilities during live interactions. Traditional tree search algorithms can expose agents to these risks due to their exhaustive exploration of potential actions, which can inadvertently lead to sensitive information submission or unintended transactions. By utilizing model-based planning, WEBDREAMER allows agents to simulate interactions within a virtual environment, thereby reducing safety risks while maintaining the ability to explore and plan effectively. This simulation-based approach enables the agent to evaluate potential outcomes without directly engaging with live websites, making it a more practical solution for navigating complex web tasks. Ultimately, WEBDREAMER leverages the capabilities of large language models, LLMs, to create a versatile model that can safely navigate the dynamic landscape of the Internet.
How does the proposed WEBDREAMER framework work? Please illustrate the method step by step, including how it utilizes LLMs for simulation and scoring.
The WEBDREAMER framework operates through a model-based planning approach that leverages large language models, LLMs, for simulating interactions in web environments. First, the agent generates candidate actions based on the current state of the environment. For each candidate action, WEBDREAMER employs the LLM to simulate the potential outcomes by predicting state changes and imagining subsequent actions, creating trajectories of a specified length, h. Next, the LLM evaluates these simulated trajectories using a scoring function, categorizing them as complete, on track, or incorrect, which allows the agent to assess their effectiveness in achieving the task objective. Finally, the agent selects the action corresponding to the highest scoring trajectory and executes it, iterating this process until the task is completed. This method effectively balances safety and performance by allowing the agent to explore possible actions without directly interacting with live websites.
Can you walk me through a simple yet illustrative example of how WEBDREAMER simulates the outcomes of actions and chooses one to execute? What are the key steps in this example?
In WEBDREAMER, the simulation of action outcomes begins with the agent generating candidate actions based on the current state of the environment. For instance, if the agent considers 3 potential actions, it uses the LLM to simulate 2-step trajectories for each action. The first key step involves the LLM predicting the state changes resulting from executing each action, which is done by generating concise natural language descriptions of the expected outcomes. Next, the LLM evaluates these simulated trajectories using a scoring function that rates them on a scale of complete, on track, or incorrect, indicating their progress toward the task objective. Finally, the agent selects the action corresponding to the trajectory with the highest score and executes it, repeating this process iteratively until the goal is achieved. This structured approach allows WEBDREAMER to effectively navigate complex web environments while minimizing risks associated with direct interactions.
What are the theoretical and practical benefits of using WEBDREAMER compared to traditional planning algorithms, especially in the context of safety and real-world applicability?
WEBDREAMER offers significant theoretical and practical benefits over traditional planning algorithms, particularly regarding safety and real-world applicability. Theoretically, it employs model-based planning that allows agents to simulate interactions within a virtual environment, thereby reducing the inherent safety risks associated with live website interactions, such as submitting sensitive information or executing irreversible actions. Practically, this simulation-based approach enables WEBDREAMER to explore potential outcomes without the dangers of real-world execution, making it more adaptable for complex web navigation tasks. Additionally, while traditional tree search algorithms may yield superior performance in controlled environments, they are often infeasible in real-world applications due to their safety limitations. WEBDREAMER balances performance with practical usability by iteratively simulating and evaluating actions. Overall, WEBDREAMER's design not only enhances safety, but also optimizes the planning process for dynamic and unpredictable web environments.
How did the authors validate the effectiveness of WEBDREAMER? What datasets and benchmarks were used, and what metrics were employed to evaluate its performance?
The authors validated the effectiveness of WEBDREAMER by evaluating it on two representative benchmarks, Visual Web Arena, VWA, and Mind2Web Live. VWA consists of 910 tasks across 3 locally hosted websites, while Mind2Web Live includes 104 tasks spanning 69 real-world websites. The evaluation metrics employed included a scoring system where simulated trajectories were assessed on a 3-scale response: complete, 1, 0, on track, 0, 5, or incorrect, 0, indicating progress toward task completion. The results demonstrated substantial performance gains over existing agents on both benchmarks, highlighting WEBDREAMER's practical value despite its conceptual simplicity. Additionally, while tree search with real interactions showed slightly superior performance on VWA, the authors emphasized the infeasibility of such methods in real-world applications due to safety risks and irreversible actions.
Based on the results presented in the paper, what were the significant outcomes achieved by WEBDREAMER, and how do they demonstrate the framework's advantages over existing methods?
WEBDREAMER achieved substantial performance gains over existing agents on 2 benchmarks, Visual Web Arena and Mind2Web Live, highlighting its practical value despite its conceptual simplicity. While tree search methods showed slightly superior performance in controlled environments like Visual Web Arena, they are often infeasible in real-world applications due to safety risks and irreversible actions. In contrast, WEBDREAMER's simulation-based approach balances performance with practical applicability, allowing for safe exploration of complex web environments. The framework's ability to leverage LLMs for simulating action outcomes and evaluating trajectories demonstrates its effectiveness in navigating the dynamic nature of the web. Additionally, ablation studies confirm that the simulation stage is crucial for planning, as removing it resulted in only marginal improvements compared to the reactive baseline, underscoring WEBDREAMER's innovative approach to model-based planning.